Hi everyone, this is me Manas. Welcome back again in our channel What You Need. Hope you everyone are well. In this video we are going to learn about the basic concept of relation and functions. Already we have learned the basic concept of relation. Now today we are going to learn the basic concept of functions and types of functions. So don't wasting time, let's get started. One thing, please subscribe my channel and like the videos, also share with your friends. Please subscribe, okay, don't forget to subscribe my channels. So let's start it. Today we are going to start the continuing the earlier videos. That means in that last video we have left out the equivalence relations. Now today we have need to learn about just a simple concept of congruent modulo. So this is a simple concept. What congruence modulo? So this is very important for doing the some simple sum. So this is too much easy. So we'll learn using some examples. So let us take an example that 13 congruent 3 modulo 5. That means this 13 congruent 3, this means 13 subtract by 3, what will be getting? 10. So modulo 5 means if we divide this by 5, then need to remainder is 0, then we can write like this way. So that means similarly 5 congruent 5 modulo 5. Okay, similarly that means if we want to write 9 congruence modulo 5, then what we have need to write? We have need to write divided by 9, 6. Okay, we want to write 9 congruence modulo 6, then 6 ones are 6, the remainder is 3. That means we can write 9 congruence modulo 3 modulo what? 6. So I hope you have understood it easily. So similarly on another examples, minus 2 is also 4 congruent modulo what? 6. So let's try to solve this. Now coming to our main point, what? Function. First of all we have need to know about what is function. So basically function, so sometimes we call this function is also another name that is mapping. What? It is mapping. So function is also called what? Mapping. So for understanding the functions, let us take two sets. Let be two non-empty sets. Suppose there exists a relation f from A to B such that each member of A associated with a unique element of B, then F is called function or mapping of A to B. Therefore, function f is f of A to B is denoted by f of A to B, or it can be written as like this way also. So for better understanding, we will taking an examples of functions. So before taking examples, we have need to learn again the definition of functions. So what is the definition? A and B be two non-empty set. So you have know that what is non-empty set. That means there is some element in set A and B. Then suppose take a relation from F to F, from A to B, such that each element of A, that means each and every element of A associate with some element of B. Okay, that means you can take a set A and this is B, this one 1 2 3, let A B C D, then let us take 1 associate with A, 2 associate with B, suppose 3 associate with D. The definition is says that from A to B such that each member of A associate with a unique element of B. That means each element of A, here each element have a unique element in B. That means 1 is related to A, 2 is related to A, similarly 3 is related to D. That means 1 has a unique element A, 2 is also related with unique element B, and 3 is also related with a unique element of D. Again take an example A and B. Here let us take 1 2 3, same example X Y Z W. So 1 is related to X, 2 is also related to X, 2 may be also related to X, 3 also may be related to X. That means 1 has a relation with X, a unique element, but one cannot make relations with two elements, let suppose X and Z, then this is not becoming relations because 1 has not a unique element in B, 1 related with two element with B, which is contradict our definitions. So you can take another examples for functions. Let us take, these are set B and set A. Suppose P Q R, these are name of some mothers. Okay, this set is mothers, and these are child. Okay, let us take A B C D E. So as we know that one mother can be born two or more than two children. Okay, that means suppose P is a mother of A and B is also children of P. Okay, that means B can also call P as a mother and A is also called P as a mother, but A cannot say that P is also his mother and Q is also his mother. This is not an relation. That means mother always a unique person. A person cannot have two mothers. Okay, two biological mothers cannot make a single child. That means any mother can born 1, 2, 3, 4 children, but two mothers cannot born as same children. Okay, so what I want to tell you, so this is not any relations. Okay, so this is not an relation. So I hope you have understood the definition of relations. Definition of relation says that each element of A has a unique as each element of A related with a unique element of set B. I hope you everyone understood the definitions. If you will be getting any problem to understood the definition, please inform me in comment, as well as you can send also mail. We have we already understood that there are two set A and B. Here the set A is called what? Domain of the function. Okay. If you ask that write the domain of functions f, then you have need to write simply the set A. Okay, not only A, which set is present in the first position, that set is called what? Domain of that function. And after that, set B is called codomain of that set, not set of that function. If again, if A belongs to A, then the element in B which is assigned to A is called the F image of the function. Okay, that means in the set, let us take A 1, 2, 3 and B x, y, z. If 1 related to x, 2 related to y, 3 related to z, then the F image of 1 is x, F image of 2 is y, F image of 3 is what? Z. And simply it is denoted by let us f of 1 is equal to what? X. That means pre-image of f of 1 is what? X. Okay, I think you have understood. If you will be getting any problem, please inform me. Okay. So here we have learned the image, f image is what, x y z, and the pre-image of x y z are 1 2 3. Pre-image of x is what, 1, pre-image of y is what, 2, pre-image of z is what, 3. These are called pre-image. So simple definition of pre-image is what, if f of x is equal to y, then x is called what, pre-image of y. Now coming to next topic, what, value of functions. Value of a functions. This is very simple. If a function f of x, if x replaces by a, then f of a is known as the value of function for x is equal to a. Example, suppose a function f of x is x square plus x plus 5, and suppose x is equal to 3, then the value of function at x is equal to 3 is what, 3 square plus 3 plus 5, what, 3 is 9 plus 3 plus 5, what, 12 plus 5 is 17. This is the result of value of the function. Range of a function. So what is range of a function? Look here, a function f a to b, then as we know that definitions, each element of a correspond to one and only one element in b. Okay, that means for making a function a and b, 1 2 3 p q r s t, so the definition says this: each element of a connected with an unique element. That means in set A there is not a single element remaining which have no f image in set B, but in set B some elements are remaining which not has p image. That means this is relations. But if there is a element is remaining which has not any f image in set B, let us suppose this is 4, this 4 not related with any element, then this not become a relation, because 4 not related with any one element of P. Why? Because the definition says that each element of A related with a unique element of B, so we can't remain any element in set A. So then which element are related with set A? That subset of set B. Here the element of the related with set A is what? P and Q and R. These three elements related to A. Then these three set of these three element is called what? Range of these functions. Okay, what is called range of the function f. F is what? P, Q, R. Because P, oh sorry, this is not R, this is S. P, Q, S. Now we are going to learn about some uh, different types of functions. Okay, so number one, linear function. So what is a linear functions? A linear function is a function of degree 1 and defined by y is equal to ax plus b. So a linear function is a function of degree 1. Okay? Those equations which are linear, that all our equations are called what? Linear functions. Next is what? Constant function. Okay, a function f x tends to y is a constant function if f of x is equal to c. That means if the value of function is become constant, then that type of functions is called what? Constant functions. Identity function. F function f x tends to y is known as identity function if f of x is equal to x for all x belongs to x. That means if the value if a set, let us suppose take an example, this 1 2, this is set A, and this is also 1 and 2, this is set B, and there is a relations f1 is connected with 1, 2 is connected to 2, then f of 1 become 1, f of 2 become 2. These are what type of functions? These are identity functions. So these two sets must be what? Same. Absolute value function. So what is absolute value functions? F functions f a tends to b is defined by f of x is equal to mod x is equal to, mod x means the value is either positive or negative. What is given we don't know, so we are taking two parts for absolute value functions. What one is positive, another is negative. Positive start from 0 and negative less than what 0. So x is less than 0, the value of x is all are in negative. Now we are going to learn about types of functions. Types of we have learned the earlier are some common functions. Now coming to our next topic, types of functions. Number one is 1 function. 1 it is also called injective, or sometimes we can write like this also. Okay, 1 functions. So what is definitions of 1 function? A function f a to b is called a 1 function if listed elements of a have that means one image one element has have a single what f images. That means pre-image of elements are always single. Some examples, let us take two set. This is a 1 2 3, this is b p q r. 1 is related to p, 2 is related to q, 3 is related to r. This is one function. Okay, similarly another, suppose this is x, this is y. Let us suppose u p w a e I o u. Suppose u related to a, p related to I, x related to u, then these are also what 1 function, because each element of x have a unique f images in set what y. Also the element of x have single f images in set y, and all the element of y have a single f pre-images in set x. But this type of x this type of relations is not a what 1 relations. Look here, let us suppose 1 2 3 u p. So 1 is related to u, 2 is also related to u, 3 is related to p. So this is a function, but this is not an 1 functions. Why? Because there are two f images of u. That means what are not f image, pre image. What are pre image of u? Then you can write, if you if I have asked pre image of u, then you have need to write 1 and 2. So that means according to definitions we have need only a single pre image in set A. Many one function. So what is many one function? A function many one function if there exists at least two distinct elements in A whose images are same. Okay, whose F images are same. So this is example A 1 2 3 B P Q R. So 1 is P, 2 is Q, and T is also related to Q. Then we call it what? Many one relations. Now coming to next topic, surjective functions or on to functions. So this is what a function f a to b is said to be onto if every element of a no not a every element of b is images of some element of a. That means if we are taking two set a 1 2 3 b p q r, then according to definitions there is not remaining any one element. Okay, so then we call it is what? Onto relations. Okay, this is onto relations 1 1 also, and then suppose 1 2 3 a b 1 is related to a, 2 is b, 3 is also b, then this is also one on two relations. Okay, because there is not a single element are remaining. Okay, if there is any element is remaining, let us take an element c. If c is remaining, then this is not become what? Onto. So what we have understood? We have understood that each and every element of b are need to free images in a. Into. So into is just opposite of onto functions. That means there must be any one elements need to remaining here which is not a free image in set a. X y z suppose this is 1 2 3 4, then x is related to 1, 2 is related to 2, and z is related to 3, then 4 is remaining here. So this is what into functions. So into definition is that there is at least one element need in set B which has not any pre-images in set A. Okay, then we call this type of relations are what? Into functions. So these are some basic concept of functions. Thank you everyone for watching my videos. We'll start our next video. We'll continuing to solve the problems of our exercise from exercise 1.1 till the exercise finishings. I will continue this video series. Keep support with me and with our channel. Please subscribe, and good night everyone. Thank you.